Okay, hi class. So now let's continue with 2.2 absolute values. Okay, are you familiar with the word absolute? Okay, usually we will play with the sign of modulus, that is absolute. So actually, what is absolute? Okay, absolute value of A, or we represent it as modulus A, is actually the distance of point A, alright, on the real number line, on our number line, okay, from origin. So here let's draw a number line. Here we have 0. Okay, you have A here. So what is the distance here? The distance is A. Okay, and if you have the negative A here, the distance is also, we can say as A, because distance is always positive. Okay, so on how we are going to represent this, actually we can write in form of a modulus, which is modulus A equal to A, and modulus negative A will also get A. Okay, thus, right, our definition of modulus A is actually, we have A if A greater equal to 0, and we have a negative A if A less than 0. Okay, you can see the symbol here. Here is less than 0, means negative only. Here is 0 and above. Okay, so one is positive, another one is negative. Or we also have another definition, okay, that we will use later. Our modulus A is also the same as sed A squared. Right, so this is our definition of modulus A. Right, so now we will continue with looking at our properties of absolute values. Alright. Okay, let's see properties number 1. Modulus A will always be greater or equal to 0. Right, it is easy, right? Because we know that modulus A is equal to A. Modulus negative 8 is also equal to 8. Modulus 0 is equal to 0. So our value will always be greater or equal to 0. Right. We go to the number 2. We have modulus A equal to negative modulus A. Alright, you can see the example before. Alright, either it is positive or negative inside, the final value will be the same. Okay, to the number 3, we have modulus A plus B is equal to modulus A plus B. Oops, now we change the position, equal to B plus A. Okay, you just rearrange the number, you will still get the same answer. Alright, next, number 4, we have a modulus A minus B is equal to B minus A. So here, let's choose a number between two of them. Alright, this one, let's choose number 4 plus 7 is equal to modulus 11. So it is equal to 11. So we arrange it, we get rearrange it to plus 7 plus 4 is also equal to 11 modulus 11, so it is equal to 11. So it is the same. How about this one? 4 minus 7 is equal to negative 3. Modulus negative 3, we get 3 at the end. modulus 7 minus 4 is equal to modulus 3. So at the end we still get 3, so it has the same value. Okay, when we are talking about this one, I want you to stay alert. Plus, yes, modulus negative 3 equal to 3. Okay, and modulus 3, you get 3. Okay, let's say you have number 3, but you can't change it to be modulus negative 3. Alright, you get what I mean? Is it from modulus? It's okay, the value will be positive, but from a value, you can change it to modulus negative inside. Okay, because this happens. Alright, so next we look at properties number 5. Alright, what do we have? Because we have add, we have subtract, of course we will have multiply. Alright, our multiplication is modulus AB. You multiply both of it is equal, you multiply it 1 by 1. Okay, you multiply B. Do you want an example here? Let's give a simple number. 2 multiplied by 3 is equal to modulus 6. Alright, so it is equal to 6. So we change the direction. We change it as individual multiplication. So it will be modulus 2 multiplied with modulus 3 is equal as 2 multiplied 3. We get 6. So it is the same. Okay, next, because we have already have multiply, we have divide. Okay, division. Alright, so we have our properties A. If modulus divide everything inside is equal as the numerator, modulus of numerator divided by modulus of denominator, where the denominator is not equal to 0. Okay, so let's prove for this one. We have modulus 7 divided by negative 4. Alright, so it is equal to 7 over 4. But if you multiply it separately with its own modulus, so modulus 7 divided by modulus negative 4, so you will have 7 divided by 4. So it is the same value. We'll apply all properties that we know by solving this absolute equation. Absolute, the symbol, equation is here. Right, okay, so, okay. So we continue with our 2.2 absolute values. How we're going to solve absolute equations of form. We will have 4 forms. You can see here, modulus equal to constant without modulus, modulus linear equal to linear without modulus. So you have modulus linear on the left and equal to modulus linear on the right, and you have a modulus quadratic equal to a constant number without modulus, right? So let's label it as form number 1, form number 2, form number 3, and form number 4. Let's look at form number 1. We have modulus AX plus B equal to C. Okay. It can be... Alright, so let's give you an example. Okay, for example, you have equation modulus X minus 7 equal to 2. Okay, so how we are going to solve this is write down on the left hand side as x minus 7 equal to 2, or okay, here you have to use the symbol or, okay, or union. Okay, next we will have x minus 7 equal to negative 2. So our solution is here is 9. However, here it will be 5. Thus our answer will be in this form. In solution set, we write in solution set, so it is 5 and 9. Okay. Okay, so we look at so let's make it as the form here. We go to the form number 2. For form number 2, we have a modulus linear inside and we have linear equation outside without the modulus. Alright guys, let's see, I give you an example. We have modulus x minus 2 equal to 10 minus 3x. Alright, so on the left we will have x minus 2 equal to 10 minus 3x union or x minus 2 equal to negative 10 minus 3x. Okay, let's solve for this one. We will have 4x equal to 12, so x equal to 3. Next one we have what do we have? We have 3x here. 3x means that it can be 2x, negative 2, 8, so x equal to 4. Alright, so here when you have x inside modulus and x outside modulus, alright, outside modulus, you need to check your answer. Alright, so let's check our answer. For x equal to 3, we try to calculate left hand side is equal to 3 minus, we substitute in the original equation. Alright, so our original equation is here. So 3 minus 2 is modulus 1 is equal to 1. Our right hand side we have 10 minus 3 multiply 3, we get 1. So left hand side is equal to right hand side. So x equal to 3 is our answer. Okay, next we also need to check for x equal to 4. We start with the left hand side. Is modulus 4 minus 2 equal to modulus 2 equal to 2. Our right hand side is 10 minus 3 multiplied by 4. So 10 minus 12 is negative 2. So 2 and negative 2 here is not the same. Okay, thus I can write it as left hand side is not equal to right hand side, so x equal to 4 is not the solution. Thus our final answer is only x equal to 3. Okay, yes, this is the highlight that I told you before. Because the value is negative, it will be maintained negative. You cannot, alright, suddenly it is negative 2, because you want to make it 2, you want to put the modulus sign and make it 2. It is wrong. Okay, you cannot put the modulus as whenever you want. No, it cannot. Alright, it can only be used if we have the modulus sign here. Okay, and another highlight is if it is absolute equation. Alright, because we know that we want to separate them into two parts. One is positive and one is negative. Alright, we will use the symbol or here. Okay, union. Different with before. What do we have? For before this, we use intersect for our inequalities. Either it is linear or quadratic. Okay, we use symbol n because we separate it from one equation into two and use the symbol n. But here for absolute, you will use the symbol union or you cannot use n. Okay, please see the difference between them. Okay, so here this is our highlight. When you have modulus x and x outside the modulus, so you need to check the answer. So here we need to check.